So now we have divided, we have multiplied, we have subtracted our compare step, and we are going to bring down our negative 15. So now we have a 3w into a 9w goes 3 times, and 3 times 3w is 9w, and 3 times negative 5 is negative 15, and we're subtracting, so we change both signs, and both go out evenly, and we wind up with 2w plus 3 is our quotient, which is exactly what we wound up with when we canceled. And that works out very nice when it works and when it comes out evenly so that we can factor. However, this one does not come out evenly. So I'm not even going to try to factor it because I know that it's not going to factor. So I'm going to do long division, and x will go into 3x squared 3x times. So 3x will go above the x column. 3x times x is 3x squared. 3x times negative 4 is negative 12x. I'm subtracting, so I change both signs and add. There's my compare step, and add 1x. Minus 1. I bring down the next number. X goes into x one time. 1 times x is x, and 1 times negative 4 is negative 4. I'm subtracting, so I change both signs. This goes out, and this becomes a 3. Okay, so now 3 is my remainder, and I will put my remainder over my divisor. So plus 3 over x minus 4. Okay, now we're going to talk about how we go about checking this answer. So I'm going to get another board over here, and I'm going to multiply. Remember, we multiply to check. So I'm going to take the divisor and multiply it by what I just got as my quotient. Okay, so I had, this was my quotient, 3x plus 1 plus 3 over x minus 4. And then this was my divisor. Okay, so this was my original problem here. I'm taking my quotient, and I'm going to multiply it by my my divisor, and hopefully I should get back my dividend. So what I want to show you now is how to multiply that back easily when you have a remainder. Okay, if you don't have a remainder, it's easy because you'll just FOIL it together. Or if it's longer, you would do like a distribution. But we've got this remainder. So what we're going to do is deal with our remainder first. Since our remainder has an x minus 4 in the bottom, we're going to keep this x minus 4 together, and we're going to do the remainder first. So instead of doing this times this, and this times this, and then this times this, I'm going to take care of the remainder, and then I'm going to forget about it. So I'm going to keep this all together, and I'm going to multiply it by 3 over x minus 4. And x minus 4 times 3 over x minus 4 is just 3. So I'm going to put this plus 3 down here, and then I'm going to call that done. All right, so I'm just going to remember that I have 3, and now I'm going to distribute. I'm going to break this apart and distribute it. So I'm going to take just the x part, and I'm going to multiply by each of the remaining terms. So x times 3x is 3x squared, and x times 1 is x. All right, so then I'm done with the x. So now I'm going to take the negative 4 and distribute. So negative 4 times 3x is negative 12x, and negative 4 times 1 is negative 4, and then I have my little 3. So now I'm going to add together my like terms. Now 3x squared has no like terms, so 3x squared stands alone. Okay, I've got an x minus a 12x is a negative 11x. I've got a negative 4 plus a 3, which is a negative 1. Now, was 3x squared minus 11x minus 1 what we started with as our dividend in the problem? And yes, it was. So we multiplied this by this to get the dividend, and we checked our answer, and there it is. Okay, so we got back to our original dividend, which is what we were trying to do. Okay, so now we're going to work on another problem of long division, which will be t cubed minus 3t squared minus 7t plus 6 divided by t plus 2. Whew, that's a long one, okay? So this time we have 4 terms divided by a binomial, okay? So we're going to start the same way. T goes into t cubed t squared times. So the t squared is going to go above here. I didn't leave myself much room, but that little thing is a t squared, okay? So t squared times t is t cubed. T squared times 2 is 2t squared. We're subtracting, so we change both signs and we add. This goes out. That's my check. And I end up with a negative 5t squared minus 7t. So t into minus 5t squared is minus 5t. And minus 5t times t is minus 5t squared. Minus 5t times 2 is minus 10t. I'm subtracting, so I change my signs and I add. Negative 5t squared, positive 5t squared, those cancel as they should. And 10t take away 7t is 3t plus 6. And now t goes into 3t 3 times. 3 times t is 3t. 3 times 2 is 6. I'm subtracting, so I change both signs and I get a 0 remainder. Okay, so that's an example of a binomial going into 4 terms. Okay, so we're going to do one more that has a remainder here. So we can practice with that one more. So one more time. So 6y cubed plus 5y squared minus 7y minus 5 divided by 2y plus 1. Okay, so here we're going to go to 2y into 6y cubed, which is 3y squared. So 3y squared will go above the y squared column. 3y squared times 2y is 6y cubed. 3y squared times 1 is 3y squared. I'm subtracting, so I change both signs and add, and I wind up with a 2y squared minus 7y, and 2y will go into 2y squared y times. So I'll come and put a y up there above the y column. Y times 2y is 2y squared. Y times 1 is y. I'm subtracting, so I change both of my signs. This goes out, as it should, negative 8y. Okay, so now I bring down my minus 5. And I get 2y into negative 8y. And that will go negative 4 times. So negative 4. Negative 4 times 2y is negative 8y. And negative 4 times 1 is a negative 4. I change both signs. I'm running out of room. So that minus becomes a plus. That minus becomes a plus. This goes out as it should. And then I've got negative 5 plus 4, which is a negative 1. Okay. And the negative 1 is going to go on a remainder. I'm all out of room. So let's put our remainder here. And the remainder is going to be right here. Negative 1 over 2y plus 1. Okay, so it's all of this and that little bitty remainder. That would be the answer, and that is correct. Now when we go to check it, we would multiply, but I would treat this all by itself, multiply this by this, and just say, okay, I've got a -1 resulting from that. Then I would put that away and I would distribute the rest of it to make sure that it worked. Okay, so now we're going to talk just a minute about synthetic division. Okay, and synthetic division is very nice to use when your divisor is just x minus or plus a constant. Okay, so we're going to go back to one that we did that came out evenly, and it was t cubed minus 3t squared minus 7t plus 6, and we're going to divide by t plus 2. Yes, okay. Now, when we finished doing this, remember our answer was t squared minus 5t plus 3. Okay, so we've already done this one, and this was our answer. Okay, so we're going to do this one using synthetic division. Okay, and synthetic division is a little shortcut. To use synthetic division, we must first make sure that we have everything in descending order with nothing missing. And t cubed would be just 1. We only write down the coefficients. 1, -3, -7, and 6. So all I have to do is write down the coefficients. Then I write the opposite of the 2 right here. Okay, this is really cool. It works very nicely. So the pattern is I drop the first one down and I multiply 1 times a -2 to get a -2. And then I add and I get a -5. And I multiply the -5 times the -2 to get a 10. And then I add to get a 3. And 3 times -2 is -6. And then I add to get a 0, which means there is no remainder. Now, when I go back, this is my quotient without variables. Since I started with a t cubed, my quotient will back down 1 because I'm dividing by a t. So this is going to be a t squared and a t and a constant, and this was my remainder. So t squared minus 5t plus 3 is my remainder, t squared minus 5t plus 3. Now that was just a little extra because we don't really go over synthetic division in our intermediate, but you will be doing that a lot when you get to college algebra. So I thought I'd throw that in just as a little handy thing to have. Now, let's do one more thing in here, because when you are dividing, it is most desirable to have your divisors, your dividend and your divisor in descending order of the variable. Okay, so let me show you this one right here. This is one that does not come out evenly, but it also has a missing term. Notice that we're going from cube to square all the way down to the constant. So remember how things have been nicely lining up in all of mine. In other words, in this one right here, we had t cubed, we had all the t squareds lined up, all the t's lined up all the way down, and then my constants lined up. That's what we want. A nice, neat, orderly, that way we won't misadd or add unlike terms together. So on this one, I'm going to do a little bit of housekeeping. And I'm going to take this -32 and I'm going to slide it down a little bit. And I'm going to put in what I call a dummy variable. And the dummy variable is just going to be a 0r. And that 0r is going to hold the place for all the r's. So now I've got cube, squared, to the first power constant and divided by r minus 3. Okay, so now when we divide, we're going to have a spot for everything. R goes into 2r cubed, r squared, 2r squared times, so 2r squared goes above the r squareds. 2r squared times r is 2r cubed. 2r squared times negative 3 is negative 6r squared. I'm subtracting, so I change both signs and add. And then I get a 3r squared plus a 0r. R goes into 3r squared, 3r times. And now I've got a spot right above the r's to put that 3r. 3r times r is 3r squared. 3r times negative 3 is negative 9r. Change both signs. And now I've got a 9r, because this cancels out, minus 32. And now r into 9r goes 9 times. And 9 times r is 9r. And 9 times 3 is negative 27. I change my signs and I add. And that's going to be a negative 5 remainder. So I'm going to have all of this and then negative 5 over r minus 3 will be right up there next to my 9, but I have no room for that one. Okay, and that is the correct answer. Okay, then in our lesson, we moved into just a little bit of notation. Okay, our function notation for division is f over g of x. And remember, that notation does not mean that the f over g is multiplied by x. It's saying the f function and the g function are both functions of x, and I am dividing them. Okay, so that is the notation for division. And when we go to substituting in, that makes it very helpful. So let's just do one of those. Okay, they're giving me two functions. 6x squared minus x minus 2 is f of x, and g of x is 2x plus 1, and they want me to talk about the domain of f over g of x. Okay, now remember, the domain is what x can be. So if I'm going to take this f function, 6x squared minus x minus 2, and I'm going to divide it by the g function, which is 2x plus 1, what is going to be a problem with domain? So whenever we're talking about domain, it's really kind of like innocent until proven guilty. What is x not able to be? And then we assume that x can be anything else. Okay, the key here is that the denominator cannot go to 0. So basically, in your mind, you set it equal to 0. 2x plus 1 is equal to 0. And then you figure out what makes that happen. If I take the 1 away from both sides, I get 2x is negative 1. I divide by 2 on both sides, and x is a problem when it's negative 1/2. Okay, so I would say x is all real except that x cannot be negative 1/2. All right, so the way that I would write that, if x could not be negative 1/2, how would I write that in interval notation? Okay, remember that x cannot be negative 1/2. It would be, in set notation, it would be the set of all x such that x cannot be negative 1/2. Okay, that would be, okay. In interval notation, I would say negative infinity to negative 1/2, excluding negative 1/2, union negative 1/2 to positive infinity. And that notation in interval means everything but negative 1/2. Okay? And that ends our 6.5. I hope having some of these problems worked out for you will make division of polynomials a little clearer for you. And this is Mrs. A, and may God bless your day.